Hey everyone, and welcome to the sixth video in this series of tutorials that will help you to collect, examine, and visualize urban informatics and modelling through digital data sources within the context of Melbourne, Australia. Hi, my name is Amy, and in this tutorial I will teach you how to create and visualize a raster file in QGIS. So let's get started. So the first thing we're going to do is to open our internet browser and go to the Urban portal. And then from here, in a new project, which in this case I've already created, we are going to refine our area down to that of the Melbourne CBD. And then from here, we are going to copy this as our bounding box. And then we're just going to adjust this bounding box to include just the part that is Melbourne CBD and Docklands, as this will be our study area for this video. Now we have our study area outlined. We are going to open the data browser and we are going to type contours into the keywords search bar and press enter. And then from our list of available data sets, we are going to choose the Thick Map Elevation Metro Contours 1 to 5 metre, as this will allow us to attain contours with the smallest contour intervals available within the Urban portal. And then in our datasets attributes, we're going to select all. And then we're going to give this data set a name. And we're going to add it to our control panel. And then we're going to close the data browser. From here, we are going to click on the spanner beside our dataset, and we are going to download our dataset as a shapefile. Once our dataset has finished downloading, we are going to show this dataset within the File Explorer and extract this dataset from its zip file. Then we are going to minimize our internet browser and open up QGIS, making sure once again that we are opening the QGIS with the grass extension. Then from here, we are going to navigate and find our dataset shapefile in order to drag and drop it into our layers section and open up a new QGIS file. We are going to rename our layer in order for us to easily identify it. And we are going to change our projection of our viewport. In order for us to view our contours within the local Melbourne region's CRS. After we have done this, we are going to rasterize our vector layer into a digital elevation model or a DEM file. In order to do this, we're going to go to Raster in the toolbar, and we are going to go down to Conversion and then across to Rasterize in order to turn our vector into a raster file. Then from here, we're going to make sure that our input layer is our imported contour shapefile, and we are going to select from the field to use for burn-in value layer options, the altitude option, as this is the numeric data field that our shapefile has that tells us the heights of the different contours in our study area. Next, as we are wanting our raster file to have the same projection as our input contour shapefile layer, we are going to select our output raster size units as pixels in order for these to match. And then, because we are wanting our output to have a high resolution, we are going to give both the horizontal and the vertical resolutions a value of 300. Next, we are going to scroll down a bit and we are going to give our output a projection extent. So in this case, we are going to choose our contour shape file as the extent in order for the area of our raster to match the area of our input layer. After these parameters have been input, we shouldn't need to customize any of the other options, so we are going to click Run in order to generate our raster file layer, and then we are going to close our rasterize window. And there you have it. We can now see our rasterized layer in our viewport. We can now change the default black and white color rendering if we would like by double clicking on the output raster layer and changing the render type in this case to a palette unique values render type. And then we're going to choose our color ramp. And in this case, we're going to go with a very psychedelic magma color variation. And in order to rasterize the different altitudes within our raster, we are going to need to classify these. And if we would like, we can also alter each individual height color as desired by double clicking on the height value option and altering it as we please. Each of the height values that are seen here mark 1 meter. Once we have done this, we can click OK. And we can now see that our raster height map has an altered color scheme. If we are wanting to go one step further and view this rasterized height map in 3D, we can go to the View tab in our toolbar and then go down to New 3D Map Height. Alternatively, you can press Ctrl-Alt-M on your keyboard. And this will open up a 3D map viewport. From here, we're just going to expand this viewport. And then we are going to click on our spanner in order to open up our configuration options. And we're going to change the terrain type from a flat terrain to a digital elevation model terrain in order to get that 3D view. And then we are going to select our output raster layer as the elevation type. And we are going to accentuate our vertical scale by doubling it. And then we are going to give our resolution the same resolution that we gave our output raster layer, which is 300. And then we're going to press OK. In order to get that 3D perspective view, we are going to hold down our scroll button on our mouse and then just move our mouse with that button still held down. And then when you're happy with the view, we can release that button and then just scroll in to see that 3D height difference. And if we click on the left button on our mouse, we can click and drag to different sections of our 3D map. If we want to accentuate our vertical projection even further, we can go back into our spanner configuration window and we can up the scale. And as you can see, that accentuates the scale even further. Alternatively to using your scroll button to alter the 3D projection perspective, you can hold down Shift and your left mouse button. And if you hold down the right button, you can zoom in and out very easily. And finally, if you hold down Control and the left button, you can orbit around the map. And voila, we now have our Visualise raster file with a 3D projection in QGIS. Thank you for watching this video on how to create and visualize a raster file in QGIS. In the next video, I will show you how to add an area attribute to a shapefile layer in QGIS. So until next time, bye!